Hi students, welcome to the session. I am Dr. K. Varada Rajkumar, Associate Professor, Department of CSE, AIML, MLR Institute of Technology, Hyderabad. In our previous class, we learned about what is a graph and different types of graphs. In this session, we will see how to represent graph. We can represent graph in two ways. One is by using adjacency matrix and another one is we represent using adjacency list. Let us see how to represent. Overview of the presentation. In this presentation, we see definition of graph. After that, we see how to represent graph using adjacency matrix and how to represent graph using adjacency lists. Outcome of this lecture, at the end of this lecture, you all are understand how to represent graphs using adjacency matrices and adjacency lists, and you construct adjacency matrices and adjacency lists for a given graph. So what is graph? So graph is a collection of vertices and edges. So already we discussed about the definition in detail in our previous class. If you want to detailed explanation about the graph definition, please refer my previous video. So what is a graph? A graph is a collection of vertices and edges. So what is a vertex? Vertex is a fundamental unit. And what is a edge? Edge is a connecting two nodes. Okay. So now how we represent the graph means G equals to, G means graph, equals to V comma E. So V is vertices, E is edges. Okay. There are two ways to store graphs into computer memory. So one is by using adjacency matrix, another one is adjacency list. Okay, so first we see how to represent graph using adjacency matrix. So first we see what is adjacency matrix. I hope you all are know what is matrix. If you represent the data row wise and column wise, so that we call as a matrix. Now adjacency matrix is a 2D array, two-dimensional array used to represent a graph. The size of the matrix is V into V, V cross V. So for example, the vertices are 5. Now what is the size? 5 rows and 5 columns. So 5 into 5, where V is the number of vertices in the graph. Each cell A of I comma j in the matrix represent the edge between vertex I and vertex j. For an unweighted graph, there is an edge between vertices I and j. The cell contains 1. Otherwise, it contains 0. For weighted graph, the cell contains the weight of the edge if there is an edge. Otherwise, it contains 0. Okay. So already in our previous class, we discussed about unweighted graph and weighted graph. Okay. So weighted graph means the edge have some cost. Okay. If there is no cost, that graph we call as a unweighted graph. Okay. So what is adjacency matrix? Adjacency matrix is a 2D array. So for example, consider this graph A, B, C. It is also a graph. Now how many vertices? 3. So V equals to 3 here. Now, so consider 3 into 3 matrix. Now, so this is the matrix A, B, C, A, B, C. Okay, so now A to B, there is a edge between A to A? No, so it is represented as 0. If there is there edge between B to B? No, so it is 0. From C to C, 0. Now consider A to B is an edge, so write 1 here. There is an edge between A to C, so write 1 here. There is an edge between B to A, so 1, B to C, 1, C to A, 1, C to B, 1. So this is the adjacency matrix representation. Let us see one more time. The adjacency matrix is a 2D array. So for this graph, So this is the 2D array. The size of the matrix is V into V. So here the number of vertices are 3. 3. So 3 into 3. So 3 into 3 means 3 rows and 3 columns. Each cell A of ij. So now this array we call as a A of ij. Now A, B. So A is I, B is J. A, B. So A of A, B. Yes, there is a edge. So we mention this as a 1. If there is no edge, then we write as a 0. For example, here there is no edge between A to B. So now mention this as a 0. Now consider this graph and represent using adjacency matrix. What is the first step? Identify number of vertices. How many vertices? 1, 2, 3, 4, 5. So what is the matrix size? 5 into 5. So A, B, C, D, E. Similarly, A, B, C, D, E. So this is the matrix. Now check. A to B is 1. A to C, no. A to E, no. A to D, no. So remaining are zeros. Similarly for B. So B to C, B to D. So 1, 1. Remaining are zeros. Similarly for C, from C to E only. So here mention 1. Remaining are zeros. Similarly for D. So from D, we have only one connection, that is A. So 1. Remaining are zeros. From E, yes, there is a edge between E to D. So 1. Remaining are zeros. So this is how we represent a graph using adjacent matrix. Now you consider this graph. Now this graph have some weights. So A to B is 4. So instead of 1, we write 4 here. B to C, 2 here cost. So write 2 here. C to E is 8. B to D, 1. D to A, 5. E to D, 10. Okay. So this is how we represent a graph using adjacency matrix. The second way to represent a graph is using adjacency lists. That means by using the linked list, we represent a graph. An adjacency list is a collection of lists or arrays used to represent a graph. Each vertex in the graph has a list that contains all the vertices that it is connected to by an edge. Here also we have, for an unweighted graph, each list contains the vertices connected by an edge. For a weighted graph, each list contains pair of vertices and their corresponding edge weights. So let us discuss with one example. Consider this graph. Now we represent this graph with the help of list, linked list. Now what is the first one? A. So A is one node, one vertex. Another vertex is B. Another vertex is C, D, E. All these are the vertices in the graph. Now I want to represent this graph with the help of lists. Means now we have connection from A to B. So here we create one linked list and connect B here. Now, so this is the only edge we have. So this is the only one. Now A to B edge is there. And similarly for B. So for B we have two edges, B to C, B to D. So here we write C and we write D. Okay. and we have only 2 edges, so mention this as a null here. So now pause the video and try to fill remaining vertices. From C to, we have only one edge for C, so from C to E, so this is the E, so here it is a end. And similarly for D, we have only A. For E, we have only D. So that's it. Okay, so this is the how we represent using adjacency list here. If graph contains some weights, now so this graph contains some weights, how we represent? Similar, but so this node have another portion to represent weight here. From A to B, what is the weight? 5, so 5 you represent here. Similarly from B to C, what is the weight? 3. From B to D, what is the cost? 8. This is the end. And from C to E, what is the cost? 7. And from C to A, what is the cost? 6 is the cost. From E to D, the cost is 8. In this way, we represent weighted graph. Okay, coming to summary of the session. In this session, we learn how to represent graph using adjacency matrix and how to represent graph using adjacency list here. So how we represent using adjacency matrix means it's a 2D array represents where the size is V into V. V means number of vertices. If V equals to 5, then we consider the 5 into 5 2D array. So each cell indicates whether an edge exists between two vertices or not. If there exists an edge, then we mention that as a 1, otherwise 0. And we represent the same graph using adjacency list also. It's a collection of lists where each vertex has a list of all vertices it's connected to. Okay, I hope you all are understand how to represent a graph using adjacent matrix and adjacent list. If you have any doubts, so place your doubts in the comment section. I will answer all your questions. Thank you.